Deep beneath the crust of an active volcano, where temperatures exceed 2,000 degrees Fahrenheit, rivers of molten rock flow like liquid fire through ancient channels carved by the earth itself. The glow is hypnotic, a churning mass of orange and crimson, hissing and crackling as pockets of gas explode into the superheated air. Most would see destruction here, an untouchable force of nature meant only to consume and reshape the land. But there are those who see something else entirely, something delicious. What if this liquid inferno, this primal element that has forged continents and swallowed civilizations, could be transformed into the rarest, most sought-after confection on the planet? What if we could take the very essence of the Earth's fury and crystallize it into candy? This is not fantasy. This is the Obsidian Confectionery. Welcome to the only facility on Earth authorized to harvest, process, and refine molten lava into edible luxury. Over the next several minutes, you will witness a process that defies logic, merges danger with precision, and transforms geological violence into crystalline perfection. Each step is controlled, each temperature calibrated, each second a dance between destruction and creation. Before we descend into the forge, if you're ready to unlock the secrets of elemental transformation, subscribe to this channel and hit the notification bell. You're about to gain access to processes most will never see. And if your curiosity burns as hot as the magma we're about to explore, leave a like on this video. Now let's begin. Lava cannot be scooped. It cannot be bottled like water or mined like coal. It must be extracted with surgical precision from thermal arteries located 300 feet below the volcano's caldera. The Obsidian Confectionery uses a patented thermal bore system, a drill bit coated in a tungsten carbide alloy capable of withstanding direct contact with magma. The drill doesn't cut. It vibrates at a frequency of 40,000 hertz, creating a resonance that allows the molten rock to flow upward through a vacuum-sealed channel. The sound is deep, a low hum that vibrates your chest, punctuated by the occasional crack of stone, giving way to pressure. As the lava rises, it glows fierce orange, almost white at the center, veins of black obsidian swirling through like ink and water. The temperature inside the extraction tube is currently 2100 degrees Fahrenheit. The air around it shimmers. The heat is so intense. Safety personnel must remain behind thermal barriers 30 feet away. But even tungsten has its limits. Every 48 hours, the drill bit begins to deform. The molecular structure, stressed beyond its design tolerance, starts to warp and lose its edge. When this happens, a fleet of autonomous thermal drones descends into the shaft. These drones are equipped with heat-resistant carbon fiber shells and magnetic clamps. They work in coordinated silence, disconnecting the compromised bit and installing a fresh replacement in under 12 minutes. The operation is critical. A warning siren echoes through the facility, a low, pulsing tone that signals all personnel to clear the extraction zone. The sound is haunting, rhythmic, almost ceremonial. During the swap, the flow of lava is temporarily redirected into holding reservoirs. The drones retreat, carrying the spent drill bit, now glowing faintly red, its surface etched with thermal scars. It will be recycled, melted down, and reforged. Nothing here is wasted. Once harvested, the raw magma enters the purification atrium. Not all lava is created equal. Volcanic magma contains silicates, metal oxides, sulfur compounds, and particulate debris. For candy production, these elements are unacceptable. The lava is poured into a containment basin lined with nano-ceramic composite, a material developed exclusively for this facility. Here, the magma rests for exactly 4 minutes, allowing heavier impurities to settle and lighter ash to rise to the surface. Robotic skimmers, guided by infrared sensors, sweep across the top layer, removing contaminants with millimeter precision. The sound is almost meditative, a slow scrape, a gentle hiss as cool air meets molten stone. What remains is pure basaltic lava, rich in iron and magnesium, the foundation of what will soon become candy. The color shifts slightly now, from chaotic swirls to a more uniform, glowing amber. But what happens to the rejected material? The impurities, the slag, the unusable fragments? They are not discarded carelessly. The contaminated lava is channeled through a secondary pipeline that descends back into the earth, returned to the magma chamber from which it came. This is done with respect, a closed-loop system that honors the volcano cycle. Some of the denser, mineral-rich slag is diverted to a separate facility where it is cooled and processed into ultra-high-temperature asphalt, used to pave roads in desert climates where conventional materials would melt. Even the sulfur is captured, filtered, and sold to pharmaceutical companies. In this place, waste is a concept that does not exist. Every molecule has value. Every byproduct has purpose. Now we reach the heart of the transformation, the moment where science meets impossibility. The purified lava, still molten at 1900 degrees, is introduced into Cryo-Fusion chamber. Simultaneously, liquid nitrogen, chilled to negative 320 degrees Fahrenheit, is released in controlled bursts. The temperature differential is catastrophic. Over 2,000 degrees in an instant. In nature, this would shatter stone. But here, under precise atmospheric pressure calibrated to 0.3 bar, the lava doesn't explode. It crystallizes. The hissing is deafening, a roar of steam and gas, and through the observation glass, you can see it happening. Molten orange droplets suspended in vapor, cooling so rapidly their outer shells harden while their cores remain liquid. Watch the colors now. Really watch them. The orange begins as a pure, molten gold, the kind of color you only see in the final moments before sunset, intense and alive. As the nitrogen touches it, the surface darkens, not all at once, but in waves. Black spreads like ink dropped into clear water, bleeding outward from the edges. The transition is not sharp. There's a gradient, a thin band where orange and black blend into a deep, smoldering rust. For just a fraction of a second, each droplet glows from within, translucent like a lantern of glass and ember. The vapor rises in slow, spiraling columns, white and dense, curling upward in patterns that seem almost deliberate. The light refracts through the mist, casting shifting shadows of orange and gray across the chamber walls. It is silent now, or nearly so, just a faint whisper of gas escaping, a soft crackle as crystals form and fracture and form again. This is the moment. This is where fire becomes stone, becomes something new. This creates a unique structure, a crystalline shell encasing a molten heart. The fragments fall like glowing snow into a collection tray below, each piece still radiating heat, edges sharp as glass, glowing faintly from within. These raw crystals are not yet candy. They are too hard, too volatile, and most importantly, they have no flavor. The fragments travel through a secondary heating tunnel, where they are brought back to exactly 800 degrees Fahrenheit, just hot enough to soften the crystalline matrix without re-melting the core. At this precise temperature, the atomic structure opens, becoming porous at a microscopic level. This is the window. Pressurized flavor compounds, extracted from ghost peppers, Szechuan peppercorns, cinnamon bark, and volcanic salts harvested from geothermal springs, are injected directly into the crystal lattice. But not just any peppers. The ghost peppers used here are cultivated in the volcanic highlands of East Java, Indonesia, grown in soil enriched by centuries of ashfall. The heat of the earth below accelerates their growth and intensifies their capsaicin content to levels 20% higher than standard crops. They are harvested by hand at dawn, when the oils are most concentrated, and flash frozen within an hour to preserve their volatile compounds. The Szechuan peppercorns come from a single orchard in the mountains of Sichuan province, where the altitude and mineral-rich water create a numbing potency unmatched anywhere else on the planet. The cinnamon is not the common variety found in grocery stores. This is true Ceylon cinnamon from Sri Lanka, aged in oak barrels for 3 years to develop a complex sweetness with notes of clove and citrus. And the salt, the finishing touch, is harvested from geothermal geysers in the highland of Iceland, where boiling water erupts through ancient mineral deposits, leaving behind crystals that taste faintly of smoke and stone. Every ingredient is chosen not just for flavor, but for story, for origin, for the way it mirrors the elemental journey of the candy itself. The infusion happens in seconds. You can see it, the way the black stone begins to take on a reddish hue, veins of crimson spreading through the obsidian like blood through capillaries. The aroma is overwhelming, a sharp, spicy heat that clears sinuses and stings the eyes even from behind protective glass. The conveyor moves slowly, allowing each piece to absorb the compounds fully before entering the next phase. Each candy must be identical, not similar, identical. The Obsidian Confectionery employs a series of hydraulic gemstone presses, each exerting exactly 12 tons of pressure per square inch. The softened, infused crystal is placed into a mold designed to mimic the facets of a black diamond. The press descends, slow and deliberate, the hiss of hydraulics mixing with the faint crackle of cooling stone. The pressure is immense, but controlled. Too much, and the candy shatters. Too little, and the shape is imperfect. The molds are cooled with circulating helium gas, dropping the temperature by 50 degrees per second. When the press lifts, what emerges is no longer a jagged fragment of volcanic rock. It is a flawless, geometric masterpiece. Translucent crimson and black, edges sharp enough to catch the light, and at its center, a faint glow, the last whisper of the magma it once was. Before any candy leaves a facility, it must pass rigorous quality assurance. Every single piece is tested. Spectrometric analysis confirms the crystalline structure is stable. Thermal resistance tests ensure the candy can withstand up to 500 degrees Fahrenheit without deforming, meaning it can be shipped anywhere on Earth, even across deserts, without melting. And then the human test. A certified taster takes a fragment, places it on the tongue. The initial sensation is cool, smooth, like glass. Then, within 3 seconds, the heat erupts, not from temperature, but from capsaicin, from piperine, from the concentrated essence of volcanic spice infused into every molecule. The taster's breath fogs the air, their pupils dilate, and they nod. Approved. This candy doesn't just taste like fire. It was born from it. But there are other tests, stranger tests, designed to push the limits of what candy should be. In the stress analysis lab, a single piece is placed against a concrete wall and struck with a pneumatic hammer, delivering 300 pounds of force. The candy does not shatter. It embeds itself into the concrete. Another piece is placed in a vise and subjected to a Class 4 industrial laser. The beam passes through the candy, refracting into a spectrum of red and orange light that dances across the observation room like a living aurora. Engineers measure the refraction index, confirming the internal lattice is flawless, without air pockets or fractures. A final test involves submerging the candy in liquid nitrogen for 60 seconds, then immediately transferring it into boiling oil. The thermal shock would destroy glass, crack gemstones. The candy emerges unchanged. It is not food, it is engineered perfection. Luxury is not just about the product, it's about the experience. Each candy is placed by precision robotic manipulator into a velvet-lined obsidian box. The interior is the color of embers, a deep, glowing orange that contrasts with the black stone exterior. The box is sealed with magnetic lock and a holographic authenticity seal, each one numbered and registered in a global database. Only 500 units are produced per quarter. The cost? $12,000 per box. Each box contains 12 pieces of candy, $1,000 per piece. But this is not candy. This is elemental alchemy. This is a taste of the Earth's core, refined and perfected. This is the final form. Born in the belly of a volcano, purified by fire and ice, infused with the world's most intense spices, and shaped into a form so perfect it resembles a jewel more than a confection. Each piece is a contradiction, cool to the touch yet burning on the tongue, hard as stone yet dissolving slowly into a symphony of heat and flavor. The finish is long, lingering, a slow burn that fades into sweetness, leaving behind a faint mineral taste of volcanic earth. This is not mass-produced. This is not for everyone. This is for those who seek experiences beyond the ordinary, who understand that luxury is not about excess, but about the impossible made real. From extraction to crystallization, from infusion perfection, you have just witnessed the transformation of one of nature's most destructive forces into one of humanity's most refined pleasures. The Obsidian Confectionery stands at the intersection of geology, chemistry, and culinary art, proving that with enough knowledge, enough precision, and enough respect for the elements, anything can be refined. Now, we want to hear from you. What element should we process next? Water from the deepest ocean trench? Lightning captured mid-strike? Meteor fragments still burning from atmospheric entry? Leave your thoughts in the comments below. And if you want to see more impossible transformations, subscribe and activate notifications. The forge is always burning, and the next element is already waiting. Until then, stay curious, stay hungry, and remember, some things are worth the heat.